In the vast expanse of the universe where light bends and time twists, two titans of the cosmos draw near. Black holes, the densest, most mysterious objects known to science. What if they collided? A cataclysm so powerful it could ripple through the fabric of reality itself. Welcome to our channel where we plunge into what if two black holes collided. A journey to the edge of existence where the laws of physics break down and secrets of the universe unfold. Subscribe for more cosmic mysteries. Black holes are the remnants of massive stars, gravitational monsters so dense that not even light can escape. For decades, they were theoretical curiosities until 2015, when humanity detected the echoes of two black holes merging billions of light years away. The collision sent shockwaves through space-time, proving Einstein right and opening a new window into the cosmos. But what if we could witness this up close? What would happen if two black holes, each a devourer of reality, slammed into each other? In this video we'll explore the science, the spectacle, and a twist so wild it might just redefine our understanding of the universe. To grasp a black hole collision, we first need to understand the players. A black hole forms when a massive star, 10 to 20 times the sun's mass, runs out of fuel and collapses under its own gravity. The core shrinks into a singularity, a point of infinite density where physics as we know it ceases to exist. Surrounding it is the event horizon, the boundary beyond which nothing escapes, not even light. Black holes come in sizes. Stellar mass black holes born from stars range from a few to dozens of solar masses. Supermassive black holes lurking at galaxy centers like Sagittarius A** in the Milky Way weigh millions to billions of suns. When two black holes, stellar or supermassive, find each other, gravity pulls them into a deadly dance, setting the stage for a collision of unimaginable power. Picture two black holes locked in a cosmic waltz. They don't crash instantly. Gravity binds them into an orbit that tightens over time. As they spiral closer, they whip around each other at speeds nearing light itself. Hundreds of orbits per second in the final moments. This dance releases energy in the form of gravitational waves, ripples in space-time predicted by Einstein's general relativity. These waves carry away energy, shrinking the orbit until the black holes merge. The event horizon of each distorts, stretching into a bridge before fusing into a single, larger black hole. In that instant, a burst of gravitational energy, more than the light output of all stars in the observable universe, erupts. The 2015 merger detected by LIGO converted three solar masses into pure energy in a fraction of a second, a blast we felt 1.3 billion years later. When two black holes collide, the merger isn't the end, it's a transformation. The new black hole, now a blend of their masses, vibrates like a struck bell, a phase called ring down, as it settles into a stable shape. Some energy escapes as a jet of matter and radiation from the accretion disks, superheated gas that didn't fall in, blasting into space at near light speed. Up to 5% of the combined mass can vanish, converted into gravitational waves, a loss that defies intuition. If this happened near us, the waves would stretch and squeeze Earth by a fraction of an atom's width. Harmless, but detectable. The new black hole, slightly less massive than the sum of its parts, spins faster, reshaping space-time around it. Now let's imagine the unthinkable: two black holes colliding close to Earth, say a few light years away. The gravitational waves wouldn't destroy us directly. They're too subtle to rip apart matter. But if the black holes were feeding on nearby stars, their accretion disks could unleash X-rays and gamma rays, frying our atmosphere if aimed our way. A supermassive collision, like two galaxy cores merging, could eject rogue stars or even destabilize the solar system's orbits over millions of years. More likely, we'd observe it safely from afar, as we did in 2015 with LIGO, the Laser Interferometer Gravitational Wave Observatory. Its 2.5-mile arms detected space-time ripples 1,000th the width of a proton. Here's the viral twist: some theorize a nearby collision could briefly open a wormhole, a hypothetical tunnel through space-time, offering a fleeting glimpse into another universe, though it's pure speculation. Black hole collisions aren't rare. They've shaped the universe since its infancy. In the early cosmos, primordial black holes may have merged, seeding the supermassive ones we see today. And there you have it. What if two black holes collided? This cosmic clash isn't just a spectacle. It's a window into the universe's heart, where gravity reigns and reality bends. What do you think? Could a collision reveal new dimensions? Are we on the brink of a cosmic breakthrough? Drop your thoughts in the comments below, and don't forget to like, subscribe, and hit that notification bell for more mind-blowing journeys into the strange and extraordinary. Thanks for watching, and we'll see you in the next stellar adventure.